Okay, so today you're going to do an introduction to metabolism, and I'm going to go through these few slides with you, and then the Google Doc that is attached on your agenda will be where you kind of record all of your answers to things. So I'm sure all of you have heard the phrase like we are what we eat, and so it's kind of what we're going to be considering is do our metabolism and the nutritional choices that we make, how does that impact our energy expenditure? There's a few opinion questions that I'd like you to answer first. So, what are, do you feel like you can eat whatever you want? And probably at your age, you're a lot more likely to be able to do that than I am at my age, even. And I know that when I was your age, that was definitely true and has changed as I've gotten older. What are some current trends that you think are considered, they're considered to be healthy, but they're actually really unhealthy? There's a lot of diet fads out there. I'm curious what your thoughts are on that. And what do you think it means to really eat healthy? I know that's a very subjective term, so I'm curious what you think that means. So metabolism is basically a stepwise process of we start out by eating food here, and we eat food, and that's our food intake. Then our body breaks it down into simpler compounds. So carbohydrates are broken down into simple sugars, fats are broken down into fatty acids, and other things like that. And then we create energy from that, and it's stored in our body so that we can repair different things within our body, and that we can have it for energy to be able to do activities that we need to do. And then once we've used up all that energy, then we have to eat more food, obviously. And so in this figure on the right, you can see that our chemical energy comes from the food that we eat in the form of carbohydrates and fats. And then we create ATP in our body. We release heat. That's why we have a body temperature, because our body is going through metabolism. And then we create waste, which is carbon dioxide and water. And hopefully you've all heard of that as cellular respiration. Okay. Um, so our body mass index is the value that they give based on our weight and our height. And there are ranges that are considered to be healthy, unhealthy, overweight, underweight, obese, all of those kinds of things. And so in this activity, you're going to be given a profile of someone, and you're going to be evaluating them on several different things and evaluating whether they're healthy or not. And one of the first things you're going to do is you're going to evaluate if they what their body mass index is. And so for this, I'm going to have you actually do like an example of a BMI. And so we're going to do a practice one here so you can kind of see what you need to do. So we're going to pretend like we have a man that is, we're going to say he is 185 pounds, and that his height is 5'9" Okay, so the equation you're going to use is shown here, and you're going to have weight in kilograms over height in meters, and then that's squared. Okay, so yes, we're going to have to do some math and some converting. I know you all just love math so much. And so I gave you the conversions here, and I'll show you kind of as a reminder of how to do that. So to get from pounds to kilograms, we know that there's 0.454 kilograms per pound. So you're going to do something like this. You're going to cancel units. So we're going to do 0.454 kilograms in 1 pound. So your pounds cancel. So if I multiply that out, it is 83.99 kilograms. So that would go on the top of your equation here. And then on the bottom, we know he's 5'9". So we need to convert that to inches first. So we know that 5 foot is 60 inches. And then we're going to add another 9 inches. So we know that he is 69 inches tall. And we know that there are 2.54 centimeters in an inch. So we're going to multiply that by 2.54 centimeters in 1 inch. Our inches cancel. And then we need to get to meters. And there is meters in meter. And then we're going to multiply across the top. So we're going to take 69 times 2. Oh my gosh, 69 times 2.54, and then we're going to divide by 100, and that's going to give us 1 point, can't be right, 69 times 2.54 divided by 100. Okay, it is right. 752 meters. All right, so that's his height in meters, and we're going to put that on the bottom, and we're going to square that. So we're 1.6 meters, and we're going to square it, and then we're just going to do the math. So 1.7526 squared is 3.07. So we're going to take 83.99 divided by that. 83.99 divided by 3.07. And that's going to give us 27.4 as his BMI. And that is technically a little overweight. So there's a lot of scientists that have actually recently said that BMI is really skewed and is not the best accurate measurement for like how healthy you are. Just because there's a lot of factors that go into that, but it is something that they use. So that's how you do BMI. Next is the basal metabolic rate. So this is the rate at which heat is given off at rest. So in baseline terms, it's the number of calories we need to maintain our vital functions. And so like our heart and lungs and stomach and kidneys and brain and liver, they all need a certain amount of energy in order to function at a basal level, a normal level. And so there's a calorie number that you can give for someone that they need at a baseline rate. And if they are getting that amount, then they can function on a daily basis and conduct normal functions for life. If you're not getting that much, then you're malnourished. If you're getting way over that amount, then that means that you are supplying your body with way too much, and that's what causes weight gain. And so the opposite, obviously, is what causes people to become like severely underweight if they're not eating enough, and their bodily processes are not going to be functioning normally. And so that's what contributes to that. So there is actually an equation for this, and it's based on whether you're male or female. And so since you used a man in the previous example, we're going to use a man in this example as well. And so we're going to use his actual weight in kilograms, which we learned was 83.99. So we're going to use this equation here, and we're going to take the BMR is going to equal 66.5 plus 13.75 times his weight in kilograms, which was 83.99 plus 5.003 times his height in centimeters. And so his height in centimeters, we'll have to go back to the previous one. Actually, just move the decimal 2 places to the right here. And so his height will be 175.26. I'm going to take that. 175.26. And then we're going to subtract 6.775 times his age, which he's going to be 22. Okay, and then you're going to solve for that. Okay, so let's do that. If we take 6.775 times 22, gives us 149.05. And then if we take 5.003 times 175.26, that gives us 876.83. And then if we take 13.75 times 83.99, 1,154.86. So then if we add that to our 66.5 and to our 876.83, and then we subtract 149.05, that gives us he needs, on a daily basis, he needs 1,949.14 calories for his basal functioning to occur. Okay, so you'll kind of do the example in your notes the same way. And then total daily energy expenditure is the total number of calories that should be consumed on a daily basis to maintain your current weight. So this is not gaining weight or losing weight. And so they take your basal metabolic rate here, which we know is 1,949.14 calories. And then they multiply it by an activity factor. So the activity factor is based on a formula that's kind of standardized, called the Harris-Benedict formula, and it's based on how much exercise you actually have. And so if someone is lightly active to extra active, then you have to multiply this daily amount by this to be able to determine how much they should have on a daily basis to not gain or lose weight. So we're going to say that he is lightly active. So he plays basketball with his friends twice a week. So we would need to use this equation here. And we're going to take that and we're going to multiply it by 1.375. So to do that, the math that we get is so he should have 2,680 calories per day. And if he eats that many, he's not going to gain any weight or lose any weight. All right. And then finally, I want you guys to kind of look up what the FDA recommends as the food intake amounts for fats, carbohydrates, proteins, sodium, caffeine, and water. And we're going to kind of talk about that as we move into the next section and you evaluate your clients for their nutritional needs.